This is Iceland, a place that offers a great opportunity to see exactly how Earth's inner heat is continually reshaping the planet's landscape. Molten rock usually lies hundreds of kilometres underground, but here, as in Ethiopia, it's much closer. Yet the effect is very different. Sulphurous fumes and bubbling hot pools hint at the power that is just beneath the surface. There are naturally heated pools everywhere on the island, which makes going for a dip something of a national pastime.
These hot springs are fabulous for relaxing in, provided you don't mind sharing your bath. The mineral-rich water is meant to have therapeutic qualities. But the people here might not be quite so relaxed if they knew exactly how the water gets heated. Right beneath us is a seething mass of red-hot, molten rock.
Just 20 kilometres beneath Iceland is a vast column of superheated rock, known as a plume. Recently, the shape of this hot plume of rock has been mapped. It's 100 kilometres wide and at least 600 kilometres deep. Created more than 50 million years ago, the plume is sustained by heat continually rising up from the Earth's hot core. But this giant plume of superheated rock has done much more than just warm up Iceland's hot springs. It also created Iceland itself. In 1963, we got to see how it must have happened. A volcano just below the sea's surface blasted its way out of the water. A new island, Surtsey, was born. This is what Iceland must have looked like 50 million years ago when it first burst above the surface. But what makes Iceland so unusual is not just that it sits above a hot plume. This small island is also shaped by the Earth's inner heat in another, much more powerful way.
This is Thingvellir. It's an important place in human history because in AD 930, a group of Icelandic chieftains gathered here to sort out their disputes. This was the world's first parliament, which then sat here for the next 8 centuries. But there's another reason why this is an important place. Although they didn't know it, those early pioneers of democracy had set up their parliament in the shadow of a most extraordinary rock face.
From the air, you can begin to see just how unusual this rock face is. It's a crack in the Earth's surface that runs for hundreds of kilometres. But what we're looking at is just a tiny part of something much, much bigger.
This is the edge of a gigantic slab of the Earth's crust which runs unbroken for 7,000 kilometres. Right from this point, under the Atlantic, across the USA, all the way to California.
It's what's known as the North American Plate. The Earth's surface is broken up into 7 major chunks called plates. They're so enormous that they can carry an entire continent and extend far under the sea. Strip away the Atlantic Ocean and you can see a long boundary between 2 of these plates that runs along the ocean floor until it rises above the waves, cuts through Iceland, to eventually join up with the rock face at Thingvellir. It's possible to see this plate boundary from a completely different perspective. This is a very cold place to go scuba diving. The water's just 4 degrees Celsius. But it's worth it. Because I'm actually swimming in the gap between the 2 giant plates that run through Iceland. To my left, the North American plate, and to my right, Europe. These sheer rock faces were once joined together, but driven by immense geological forces, the land was split apart to create these deep chasms which filled with water. It's hard to imagine a force that can move continents apart. Yet this is precisely what the Earth's inner heat is able to do. It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in 2 directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move. The lava lake at Erta is an example of the same process, but in miniature. As we've seen, the movement of hot lava drags the crust across the surface of the lake, just as the continents are pulled across the Earth's surface. To appreciate the idea of continents moving, you have to step outside human timescales and think in terms of a completely different time frame. The continents here are drifting apart at 2 centimetres every year. In my lifetime, we're talking just a couple of steps. Even in 1,000 years, that's just 20 metres. It's only when you start to think in terms of millions of years that you realise just what can happen. $225 million years ago, our planet looked very different. All the continents were joined together in a single supercontinent called Pangaea. As the plates moved, this supercontinent broke up. New oceans formed as continents drifted around the globe. It's this that has created the shape of the world we know today. But the plates never stop moving. In the distant future, our continents will once again be reunited in a new giant supercontinent. We've seen what happens when the plates move apart. But when they crash into one another, the effects are even more dramatic. The collision of the Earth's plates is responsible for the most spectacular mountain ranges on our planet. To To see how they're created, I've come to New Zealand's South Island. These stunning peaks run 500 kilometres along the west coast, forming a dramatic spine down the island.
According to Maori legend, these mountains are made of the petrified bodies of 4 gods who got stranded here on a canoeing trip to Earth. As they were attempting to return to the heavens, a big storm blew up and capsized the canoe. They climbed on board and